is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello, everybody, and welcome to SkyTour Radio. I'm Mark D'Antonio with my co-host, as always, Amanda Curran. Hey, Amanda, how are you?
I am well, thanks, Mark. How are you?
That's good. And we're also joined tonight by Daryl Mason, who will be providing some interesting facts about the upcoming stars we're going to see in the sky. Hey, Daryl, how you doing?
Hi, Mark. I'm good. Hi, Amanda. How are you?
I'm well. How are you, Daryl?
Oh, I'm fine. I'm a little cold. It's a funky day here today, but I'm hanging in there.
Nice.
Well, we are in the middle of a blizzard right now, so we have a lot of snow falling. But I do still, the show must go on. Last week, I could not speak, and so I had to cancel last week's show, and we had a replay, so I apologize for that. But tonight is a whole new show. My voice is better. There's a few little flare-ups now and then, but I'm sure that Daryl or Amanda will just kick in when I just can't talk, if it happens. It may not. But I wanted to just mention to you guys that I want to welcome all of you, the finest listeners on earth with the KGRA crew. And if you get a chance, subscribe to SkyTour live stream on YouTube. What's SkyTour live stream? Well, it's a clear night journey into the wonders of the deep sky, all courtesy of our research-grade telescope here in picturesque northwestern Connecticut at the John Zach Memorial Observatory. And we see stellar birthplaces, and we see nurseries where stars are born. Like I said, we see the remnants of dead and dying stars. We see glittering jewel boxes of stars in rich clusters. And it's also a stream where you, as the viewer, can participate. And if there's something you'd like to see, well, Amanda's my co-host on SkyTour Radio. She's also the co-host on SkyTour Livestream. And you can leave a message in the chat, and in some cases, we'll bring you on live with us, and you can talk to us. But we want to also be able to show you things in the sky that might be there. If you can see them, if you want to see them, then we'll drive the telescope over there. It's all computer controlled, all done remotely. So we have an upgraded system now. So things are a lot nicer looking in SkyTour Livestream. So check it out on YouTube, join, and click the bell to be able to get notified when we go live. All right. So if you're interested in doing more than just looking at the stars, if you want to basically take some home with you, well, then you could actually go to our website, fxmodels.com, or to the FX Models Planetary Replicas page on Facebook. And there you can go into our store where you can buy 3D printed Moon, Mars, and Pluto landscapes and craters that were taken directly from NASA data that I culled from the sources that are made available by the USGS. I've talked to those folks. They're wonderful people, and they're very conscientious. So the data I get is very, very nice. So that's something to do. And if you also still want to kind of connect with us, you can find us at SkyTour Radio at kgraradio.com. That is our email address at KGRA. Happy to hear from you. So do drop us a line. Now, tonight on SkyTour Radio, we're going to do a few really cool things. We're going to actually discuss, right up front, we're going to talk about cool tricks to see excellent NASA data on planets and moons in our solar system. There is an online repository where you can go see it all at once, and it's really cool. I'll tell you about that. Then we're going to talk about, in an exoplanet roundup, we're going to talk about the exoplanet Kepler 438b. Now, why? Because this planet around this distant star is one that is most Earth-like so far that we have ever found. Okay. And last, in our feature tonight, we're going to talk about the search for life in the solar system and beyond. And we're going to talk about how looking at the Earth and studying our own planet can help us when we look outward like that. Now, in the middle of that, Daryl is going to join us again and talk about the upcoming spring sky and some of the things we can expect to see coming up. He also has a few insights on some other things that he will let loose on you at the appropriate time. Isn't that right, Daryl?
You betcha. I'll try anyway. Hopefully I don't make a fool of myself.
No, you're not a fool. You know what? I got to tell you, the response to Daryl's presence on SkyTer Radio has been wonderful. Everybody absolutely loves Daryl. You know?
I want a raise.
Well, you know, twice 0 is 0.
Yeah, I know.
Yeah.
As long as... I'm sorry. Carry on.
No, it's fine. So yeah, that's pretty cool. You know, so Daryl will join us once in a while to tell us some really cool things, and he's here tonight for that very reason. Now, here's something. If moving forward now, as we move into our first segment, which is the cool trick segment that we talked about, you can actually see the latest planetary imagery by going out, believe it or not, to googlemaps.com. Now, we're all familiar with Google Moon and Google Earth, of course, but there is another repository that came online in 2017, which many people don't even know about. And that is that the Google Maps provides now the latest planetary imagery for many of the moons in our solar system, data culled from the New Horizons, from Cassini, Galileo, and other missions out to the asteroids and dwarf planets out there, Dawn and so forth. And it puts them in one repository. And you can go view these data. You can actually see it all in 3D, rotate the moons around, check it out, Like, for instance, if you wanted to see Saturn's moon Mimas, okay, Mimas, Mimas. Mimas has a giant crater, sometimes called the Eye of Mimas, okay? Well, it has a name. How would you know what the name is? And how big is it? Well, just from looking at the screen, you can see that its name is Herschel, okay? And it's 139 kilometers across. It tells you how it was, named and so forth, and the person who discovered it, what else they discovered in the solar system. I mean, a lot of really interesting details. So that's a really fun thing. But I'm going to tell you how to do it, because it's not something you can just go to googlemaps.com and just click on a button and you're there. It's a little weird, so bear with me and check this out. And this is probably something that will change, right? But if you go to googlemaps.com and zoom out and click the little lower left satellite, that little square in the lower left corner of the screen that says satellite, so it converts the image from that drawn cartoony view to the imagery, the satellite view. Click on that, and then it converts it to the satellite. And then just keep zooming out. And you'll zoom out enough so that you'll see the Earth as a ball in space, and then it will suddenly have the night and the daytime and nighttime sides illuminated. Okay, when that happens, on the left side, you're going to see this list of other places you can go. Just come down. All right? And that is the entry to this set of planetary imagery and moon imagery. Right? So now once you're there, and again, I'll explain how to get there once again at the end. But once you're out and you get in there and you're off exploring, you can go to places like Titan, Saturn's moon Titan, which is almost the size of a planet. And you can see the ethane lakes, liquid hydrocarbon lakes of Titan. Now, this moon of Saturn is actually a snapshot of the early Earth, except it was a location that was actually thrust into deep freeze from which it's never escaped. Now, there's thoughts that maybe one day when the sun starts to die and it swells into a red giant, Titan may be for a time a habitable location. Well, that might be true. But we won't be here to see it. We'll either have moved off the planet or moved out of the solar system entirely by then. I have no doubt we will. Okay, but you can see Titan and explore it using the Explorer. It's all there, all the radar data. You can see all the stuff that the probe saw. And it's in fairly high resolution. And, if you want to go out further, well, you can you can go out to Pluto and look at the New Horizons data. You can see the water-based mountains of Pluto. Yes, water ice-based mountains amid the surface of nitrogen ice on Pluto. Pluto's been enigmatic for a century since its discovery, by Clyde Tombaugh. And some of you know I met Clyde. I sat with him and talked to him on a grassy knoll before he was going to do an astronomy talk. And we talked about finding Pluto. This was many years ago, of course, because he's long gone. If he was alive today and could see Pluto through the eyes of New Horizons, I think, well, I think that would have just astonished him, frankly. One of my most admired astronomers I've ever had in my life is Clyde Tombaugh. Now the mysteries of Pluto are revealed to all of us by this casual exploration using, this Google Maps online. So it's pretty cool, And if you're interested in dwarf planets, you can check out these salt deposits that are erupting from Ocketer Crater on the Dwarf Planet Ceres. And you might be saying, what? Ocketer who? What are you talking about? You might remember that there was a time when the Dawn spacecraft visited Vesta, first of all, which was known to be a dry dwarf planet, and then Ceres later, which is known to be one that had more water-based material on it. Well, in some of the photos, there were these two dots in one of the craters on Ceres that looked like lights. And for a period of time, people said, oh, those are lights. There's intelligent life there. Is it a sign of intelligence? Well, as it turns out, they were actually a sign of salt eruptions, which were very bright relative to the dark soils on Ceres. When you take a picture of an asteroid, you have to overexpose it because it's very dark. And so when you overexpose it, you will take anything that's very bright, like the central salt deposits in a crater that might be white, are going to be blown out bright white and maybe even look like lights. And that's what we saw. In order to bring up the level, the background level of the dwarf planet to look normal and gray, it blew out those very bright white areas. So that started the rumor and conspiracy that there was intelligence on Ceres. But if you want to see these, the center of Ocketer Crater and these special salt lights, all you have to do is go there and click Ceres, and you can go check out Ocketer Crater. And if you don't know where it is, well, there's a whole bunch of blue labels, little blue teardrops, place marks that are available on every place you go. And you'll be able to click them and see what we're talking about. You'll see Ocketer Crater. You'll see many of the other locations. You'll see these rills, and you'll see other straight line faults and so forth. All there for you to see. It's really cool. I know I sound like an ad, but you know what? I just want to make it clear this is the most amazing online repository that is available to the general public that I've ever seen. It doesn't require a whole lot of effort to even see it. Okay, and that's what's so cool about it. Now, if you're done with the dwarf planets, you can cruise into the inner solar system and check out Mercury, check out Venus. Okay, Venus actually is like our hot neighbor, and you can check out the many, many hundreds, if not thousands, hundreds of thousands of lava flows on Venus. The radar data from through those very dense cloud tops shows them well. And the one thing about Venus that is interesting is you can look at this planet, and it has more volcanoes than any other planet in our solar system. At last count, and we can't even count them all, it had about 100,000 that we could see by one estimate. And guess what? The high-end estimate, if you count all the smaller ones, tops 1 million. 1 million volcanoes on the surface of Venus potentially. Now, how many is that compared to for the Earth? Well, the Earth has had a few thousand over the, maybe hundreds of thousands over the course of its development. But right now, we only have about 1,500 active volcanoes right now on the planet. The rest are either dormant or non-existent anymore. So it's really.
Do you think the volcanoes on Venus will ever settle?
Well, that's the thing. Yeah, that's very good question. Yes, they will over time. Venus' atmosphere is being pummeled by the volcanic outflows that had come out in the past. But right now, there's no real active volcanoes on Venus that we can tell. So might it be settled? Well, if settling means no eruptions for billions of years, then maybe Venus isn't quite there yet. But if it means no eruptions for millions of years, well, then Venus will certainly be there. So we have to define what settled means. But I know what you're talking about. You're saying, will Venus ever just have be a place we can go and not have to worry about a volcanic eruption? We can do that now. There's not a whole lot of eruptions going on Venus at this point, if any at all. Jupiter's moon Io another place you can go, is one of those places that actually has active volcanoes. And that's really interesting to see these active volcanoes on Io, because Io is being pushed and pulled by Jupiter. It's the closest moon to Jupiter, and Io's being basically made into like a Play-Doh ball. It's being squished, and that squishing causes friction, which causes heat, and that heat gets released through these volcanoes on Io that eject and erupt molten sulfur. And that's why Io has this yellowish color. And where the sulfur is molten, it shows up as more red. Because when sulfur is melted, it's bright yellow normally. It turns red. We all had chemistry sets, and we melted sulfur. It stunk. But you know what? When it melted, it turned into this red liquid. Nowhere near the heat of like molten lava, of course. Wasn't glowing, but it was red. I made more of that stuff, stunk up my room in my parents' house. Oh, man. Along with doing other things that Amanda likes to laugh at when I tell you guys. But honestly, Io is one of those places that are one of the most fascinating locations in our solar system. I was going to say on Earth, in the solar system, because it has this activity that's ongoing. The plumes that were first seen, decades ago, coming out of the limb of Io, proved to be real and not an artifact. At first, they actually thought that those plumes, because they showed up as these big round plumes that were coming off the surface, they first thought, is there another moon back there that we missed? It looks like it could be a moon behind Io. Does Io have a moon? That kind of thing. Well, of course not. It turned out to be the plumes from the volcanic eruptions of the sulfur. So it's really a strange place, a very strange place, And now, talking about strange places, if you want to go check out Europa at Jupiter, you can. You can see the latest imagery of Europa. Well, I say latest. I mean, we only had the Galileo imagery of Europa, which was many years ago, but that is the latest and greatest. And we can see these linear striations on the surface where the ice has faulted and crusted over again. And Europa is also being tugged on by Jupiter as well. And that accounts for a lot of the surface features on Europa looking all craggy. But the thing about Europa is it's a moon that's nearly the size of our own. And we think it has a deep ocean beneath that cold, icy mantle. And if that's the case, then maybe, just maybe, there could be life there. And there's a reason we think that, it makes sense to go there looking for life. And that has to do with when we look in our own deep oceans, which we'll get to in a little while. But there's 2 missions set to explore Europa, as we're going to see again shortly. And, I'll just tell you about them real quick. They're the Europa Clipper and the Europa Lander. The Clipper's going to find a landing spot, and the Lander's going to land there. So we're going to get answers about Europa in fairly soon, I should say, relative to the age of the universe. You can also enjoy Saturn's moon Enceladus. It's only a 300-mile diameter moon, but it shows signs of hydrothermal vent activity like our deep oceans. And we know hydrothermal vents here are the seat of life in the deep ocean. They're powered by chemical synthesis. Okay? There's no reliance on the sun down there. And Enceladus geysers are spewing water that has these hydrocarbon-y compounds, indicating maybe methane is being produced at these hydrothermal vents, which we have mapped on the south pole of Enceladus. So clearly, when Cassini mapped these, we saw these linear hotspots at the south pole under the ice, and that where those geysers were was along those hotspots. So it's possible that the less deep than Europa ocean that's on Enceladus might also possibly host a deep ocean vent type community. Maybe life, maybe not. But as I've always said, life will find a way. And sometimes, if you look at how life developed on our planet, sometimes all you need is an electrical charge and water and a reasonable environment, and life will form. That's happened here. Now, of course, you can explore Mars, the Moon, and even the Earth. But here's, you ready for this? This is the most fun. Okay, and this has a little challenge in it for you. If you go to that googlemaps.com, and no, they're not a sponsor of the show, okay, just so you know, incidentally. Maybe not yet. Hey, that might be a good idea. But if you want to really have fun, you can actually visit the International Space Station and take a tour. You can move yourself through it like it's Google Earth. And you can go exploring the International Space Station from the inside, location to location, module to module. And that tour alone can take you over an hour. All right. It's just a lot of fun. And it's very detailed, high-resolution imagery, so you can scroll in, you can zoom in and check out stuff. And here's one for you. This is a challenge. I want you, in the KGRA audience, take that ISS imagery, and I want you to find the bottle of hot sauce. There's actually a bottle of Sriracha hot sauce on a desk in the ISS. It's plain as day. Your mission, find it. Okay? Now,
don't give a challenge like that, because now I'm going to be distracted for the rest of the show looking for it.
I think that, you know
Am
what?
I allowed to participate?
Of course
Probably
you
not.
are.
Yeah?
No, you are. Sure you are. Why not? Because you didn't know about this before. You don't play with this. You haven't gone there before. But the
So I was thinking that one actually sounded the most interesting. I mean, obviously it's cool to look at different planets and different moons and stuff, but to get a detailed tour where you can find a bottle of hot sauce, that's pretty detailed. That sounds really cool.
Yeah, and there's a few other little Easter eggs in there too. And these aren't fake. These things are really there. Okay, brought up by the resupply ships when they went up. Okay, so I showed.
So who did this? Was it NASA that provided all these pictures, or?
Absolutely.
Nice.
Yeah, and that's really wonderful. So here's what you don't want to use Google Maps for, and this is unfortunately what most people like to use it for. What you don't want to use it for is to find strange objects lurking on the moon or on other moons and on other planets. Okay, I've seen this many times before. As the Mutual UFO Network's chief photo and video analyst, I get a lot of imagery. Look, I found a hole in Antarctica. Okay, no, that's what we call a stitching artifact, and I can explain that. But the way the data is assembled is interesting because it introduces artifacts that can be confusing and misinterpreted. And the most famous one is the holes in Antarctica. And in Antarctica, when you look in Antarctica, you say, well, I see lots of snow and ice, but what's that triangular hole? Well, that triangular hole is actually a place where all the edges of the imagery did not come together properly because the imagery just, for whatever reason, was taken at the wrong angle, at an oblique angle, whatever it was. They couldn't stretch it to fill the holes. So they left the holes. In the past, they left the holes, and people would always make these comments about them being, it's an entrance into the inner earth and all that stuff. But in fact, now, most of the time, instead of the holes, they actually fill it in with lower res data. Okay. Otherwise, the Lunar Reconnaissance Orbiter imagery that shows us imagery down to a 0.5 meter per pixel of sensor size. Okay, in other words, an object's like 30 feet across. You could see on the moon now, everywhere, front and back. If they had not filled in with lower res data, there'd be many stripes of black areas on the moon that would make the moon look like it was a Swiss cheese thing. All right, but it's not the case. You also don't want to use this for discovering, quote unquote, secret signs of life on, for instance, Saturn's moon Titan. There's a number of linear streaks on Titan, and these are the result of stitching countless Cassini images together. And where they meet, sometimes there's overlap and blending, and they create little linear artifacts. They're not real. Let me say that again. They're not real. Okay. Also not real are secret UFO bases off Malibu. Some of you have heard about that. There's bottom data called bathymetry, which is taken by either ships towing these little sleds behind them. They call them fish. And these fish will actually, generate imagery of the bottom. Well, sometimes that bottom imagery is not very accurate. Sometimes there's missed spots. And Google Earth wants to complete the picture, so they interpolate between the areas it knows and the areas that doesn't know. It fills in with false but maybe close data, and it created this little vertical cliff off of Malibu, which isn't really a vertical cliff at all. It's an artifact of the way it was stitched together. So anyway, these photos are made up of many innumerable artifacts in the imagery. And the areas that are stitched aren't quite aligned in some places. The locations where the imagery is missing and interpolated are a problem sometimes, like that Malibu base. But you know what? In the end, I think that Google Maps has an excellent set of reduced resolution imagery, and in some cases, higher resolution imagery, to have you go and explore the solar system like never before. So I would check it out. Oddly, we don't have Juno imagery from Jupiter yet. That may get out there, or the Cassini imagery of Saturn. But we'll get there. But you know what? We'll talk about that and more when we come back, because we have to take our first break for the evening. All right, so I will get back to you, and Amanda will, and Daryl will, right after this, here on SkyTour Radio. I'm Mark D'Antonio. Hey, welcome back to SkyTour Radio. I'm Mark D'Antonio here with Amanda Curran and Daryl Mason. Over the break, Daryl said, well, you should consider that if you're going to talk about volcanoes on Venus, that's one thing. But, Mars has the biggest volcano in the solar system. And he's right, of course. And we didn't quite get to that, but that's the next part. In addition, we mentioned that we don't see the Juno imagery, which is the latest probe to Jupiter's poles. I mean, stunning. They look like paintings, oil paint that's all, intermixing with each other. That's beautiful. It's all these impurities in Jupiter's atmosphere, which amount to a very small percent, actually, of that mostly hydrogen atmosphere of Jupiter. And we don't have the Cassini imagery of Saturn either. But we do have the Earth. We do have Mars to look at. And you can see Olympus Mons on Mars, the tallest volcano in the solar system. It's stunning to look at this in this Google Maps. But as I said, let's not go too far with it. Don't try to use it for something it shouldn't be used for. Try to understand, and I'll help you with that, the science of how these maps are put together before you make a misinterpretation, potentially, of what you're seeing on the map. All right? Now, you can see, besides Venus, I said you can see Mercury as well. And you can, like I said, explore it with the online version, or you can talk to Daryl and find out how you can see Mercury with your eye. And with that, I'd also like to just say, hey, Daryl, welcome back to the show. And would you like to tell people about Mercury in the morning?
Well, it's in the evening now, but sure.
That's right. In the evening, you're right. At sunset.
Yeah. Okay, people, if your weather's clear and we have a pretty narrow time frame, but if you have a fairly flat western horizon and you go out about a half hour after sunset, binoculars might help you at first, but once you find it with binoculars, it should be obvious enough to see naked eye. If you look just a little bit south of west and maybe 12 or 13 degrees up in the sky, if you hold your hand out at arm's length, the width of your hand is about 10 degrees to help gauge it, you will find what looks like a moderately bright star over in the west-southwest, and that is the planet Mercury. And binoculars in particular, or once it gets a little darker, naked eye, it may have a pink cast to it or maybe kind of an orange cast, and that is the light of the planet shining through our sunset here, which gives it that color. Mercury comes and goes pretty quick. If I remember correctly, it only takes about 88 days to orbit the sun, and because it's the closest to the sun, it never gets very far up in the sky away from the sun. its maximum, it's called elongation, western or eastern elongation, is about 18 degrees. Is as far as we ever see it get from the sun. So you have to look soon after sunset when it's in the evening sky as now, but it has or is about to turn the corner in its orbit where it's going to start dropping again from our point of view. It will wind up passing pretty much between the Earth and the sun, at which time after it will pop up in the morning sky, and it will get about 18 degrees up, and then it will drop again and repeat the whole process over and over. That's Mercury. If you've never seen it, it's pretty cool to see. If you catch it at the right time before it goes between us and the sun, or just after it goes between us and the sun when it's in the morning sky, and you look at it in a telescope, you'll actually see that it has a little tiny crescent shape like a crescent moon, but much, much smaller. But just seeing it naked eye is neat to be able to say you've seen it.
Sure.
And that's Mercury for you right now.
So this has nothing to do with the winter sky changing to the spring sky. This happens every 88 days, roughly? Or
Yes. Yeah. But it's happening close to spring right now, and it's probably the best apparition of Mercury we'll have all year.
Oh.
So
what, because it's winter, do you think? Is that why it's the best of the year? Or?
No, the sun is moving north as in the sky as we move close to spring and the equinox, when the sun will rise due east and set due west. And the farther north a planet like that is in the sky, the easier it will be to see. If the sun was in the depths of winter right now, well, Mercury would barely get above the horizon, and probably a really good chance you'd never see it at all, beyond the weather too.
Yeah. Well, that's wonderful. That's what I like. That's what I like with you about on the show, Daryl, is because you explain things and talk about things from a perspective of the visual astronomer who's looking at things in the sky with his own eyes.
Uh-huh.
Okay. And, I'm a little bit, I guess, jaded in a way because I look at things in the sky. I don't have a perfectly clear horizon, but I do have a wonderful set of horizon views with the observatory. And, of course, our telescope has a camera on it, and we pipe that signal from the camera into computers and so forth and so on. And, there is something missing for the person who wants to see visual astronomy at its best. They're not going to see it through the computer screen. They're going to see it through the eyepiece or through the binoculars. And I do want to warn folks, as you allude to, it is close to the sun. Mercury is close to the sun at all times. No matter how far away it gets from the sun, it's only, it could be the jerk of an arm, which sends those binoculars toward the sun. Or where the sun is setting, and you got to be careful about seeing Mercury and then zipping down and hurting your eyes by looking at the bright area where the sun has just set. So you got to be careful about that too. So
Absolutely.
you don't ever want to point binoculars toward the sun. Now the other thing is the planet Venus, which is obviously the next one out from Mercury. Venus, which we used to think was a sister planet, but now with that many volcanoes on it that it's certainly anything but a sister. Venus is visible in the daytime sky, and I used to show people Venus during the daytime, and it would take about 5 minutes to point to the right spot in the sky and show folks, follow my finger. Okay, you can't use a laser pointer during the day, of course. So we would actually just have people looking into the sky. And I was able to have people of all ages, young and old, see Venus in the sky. And even for a split second, because it's a tiny, tiny white dot. And I think that tiny white dot is, when you look at that for the first time and see that it's Venus, I think that really impresses you with the fact that Venus is actually quite bright. And you can see it in your daytime sky. Now, this brings to mind the supernova of 1054 AD, which was in Taurus and resulted in a supernova remnant called the Crab Nebula. And that particular supernova remnant, when the supernova exploded, of course, was obviously many, many years before. But when that light train from that supernova event finally reached Earth, that was that was actually visible in the daytime sky. And I thought that was pretty cool. Now, can you imagine seeing a bright star as bright as Venus appears in our night sky in the daytime sky? I mean, that would be frightening, you know. So I think that that's pretty interesting. That's a little side note to what you were saying before, Daryl.
Yes, may I say? Yes, people, that's why I said look a half hour after sunset. You want to be sure the sun is below the horizon before you start looking. Venus is the brightest thing in the sky after the sun and the moon. I have seen Venus in broad daylight more times than I can count. It's entertaining. There's no real science value to it, I think. But you can, hey, I saw Venus, in the daylight sky. Yep. It helps if you have the edge of a wall or a building that you can occlude the sun behind, and then look a little bit to the sun's right, as in the morning sky now, and you'll see it in broad daylight. Once you find it, you'll be certain what you found. Venus
can you see it in the daytime sky now?
If you have good weather, sure.
Wow.
Yeah. One morning at work a long time ago, I went out on the patio at break time, and a bunch of the guys were out there, and they all pointed at something up in the sky. Said, "Hey, Daryl, what's that?" Because they knew I'm the guy that asked stuff like that. And
of course,
well, it was Venus, and they all just got their minds blown because they were seeing it in broad daylight.
That's so cool.
Yeah. Venus is in the morning sky right now in Sagittarius, I want to say. Venus rounded the corner, the high point in its orbit a few weeks ago. It's now moving east a little farther every morning and coming up a little later. But if you get up before sunrise, you still see it easily over in the southeastern sky. It's the brightest thing up there. It's absolutely brilliant. There's no mistaking it for anything else.
Well, I know folks that looked at it and was waiting for the plane to come by, but the plane wouldn't move. It kept staying in the same place in the sky. And because they thought it was an aircraft, then they said it's a hovering UFO. And I got UFO reports about it because they had to be invested in it being a UFO or a plane, and when it didn't follow plane in their mind, it became a UFO rather than a planet, which is kind of funny how people leap to those different conclusions. But it's what
most
happened.
People think that Venus is the first star of the night and make wishes on it.
Did
you guys ever hear that?
I haven't myself, no.
Yeah, and that's why people's wishes don't come true, because they're wishing on Venus. And that's the first star they see in the night. I think I heard that from Neil deGrasse Tyson, actually.
Okay.
I think he was the one that said that. That's why wishes don't come true, because you're wishing on Venus, not a star.
Oh, it's a pretty thing to wish on. And Venus, was considered to be the evening star.
Yeah.
And when it was in the morning sky, it was the morning star. Actually, I think some cultures consider it to be a different object in the morning sky. Yeah. But it's the same.
Very cool. Very cool. So now, Daryl, while you're here, do you want to talk about what's happening in the spring sky? What's coming up?
Yeah. What I was intending to do was talk about the sky tonight, this time of year. We are about to move from winter to springtime. You've heard of the vernal equinox, the spring equinox. That is when the sun, in its motion across our sky, not across our sky, our motion in the sky, that is when that is when the sun will cross the celestial equator, which is the projection of Earth's equator up in the sky, divides the northern and the southern sky. When the sun is moving north on the equinox, which is about March 20th, the sun will rise due east and it will set due west because it's on the celestial equator, and it will officially become springtime. Then we'll have 6 months of more light than dark, and yay, winter will be gone.
Yeah. Let's also say equinox. Equinox means equal night and day.
Yes.
So it's a time where the day and night is actually the same length. Most people don't realize, they have to think about it, that actually night and day are not always the same length. you know,
Oh yeah.
which is kind of interesting, you know. I mean, we know that as astronomers, but most folks just don't think about it too much, you know, which is kind of cool, you know, that we can help you with that, right? Right.
Okay. What I wanted to talk about tonight is I'm going to take you across the sky from sunset to sunrise, and spring is right in the middle of that. Okay. As I said, if you wait a little after sunset, half an hour, you may be able to pick out Mercury in the evening sky over low in the west-southwest. Moving up, if you look maybe halfway up in the western sky, once it gets dark, you'll see a rather bright reddish star. Well, that is the planet Mars. Mars is presently in Aries, if I remember correctly. If you remember last July, Mars was at opposition. That was when it at its closest, biggest, and brightest. And everybody was, you know, looking forward to Mars at opposition. And then that big, huge dust storm happened, which wiped out all views of the planet for a couple of months.
Yeah.
Well, when that happened, Mars was at opposition. It was in Capricorn, just next to Sagittarius, last July in the summer sky. If you imagine you're driving in the left-hand lane, you're driving a car called Planet Earth. Well, Mars is in the right-hand lane to our outside, and it's racing to keep up with us, but it can't, so it's slowly falling behind. But it is moving, trying to do its best to keep up with Earth. And where Mars was in Capricorn last July, it has since moved all the way from Capricorn to Aquarius to Pisces, and now it's in Aries, and it's going to keep moving along behind us. It will slowly be losing ground. It'll drop a little lower every night. And it's not impressive in the telescope now as it was last summer, but you can still see it. Brightest thing up in that part of the sky, and it's quite red. That's Mars. Now then, if you wait until it's fully dark and you go out and you face south and you look straight up overhead, you will see all the bright stars of winter in a large kind of a lozenge or an oval shape. It's sometimes called the winter hexagon or the winter circle. And that's Aldebaran in Taurus, Capella in Auriga, Castor and Pollux in Gemini. And then you'll see Procyon in Canis Minor, Sirius in Canis Major. And coming on around that big circle, then you'll see Rigel, the bright blue-white star at the lower right corner of Orion. Betelgeuse will be sort of toward the middle of that oval. And if you draw the line from Orion to Betelgeuse, some people call that the winter G or the heavenly G. You just turn that oval into a capital letter G, you know. Now then, if you keep looking to the east as soon as it's dark, well, Leo should be up by then. Leo is one of the harbingers of springtime, okay? If you wait till it's before 10 o'clock at night now, all the bright stars of winter have moved to the western half of the sky. They are west of the meridian overhead, and they're going away. So you're seeing the stars of winter starting to leave us, and at that same time, by 10 o'clock at night, Leo is going to be high up in the east, on the east side of the overhead meridian. And hey, when you see Leo up there like that, springs are coming, okay? I'm going to skip forward some. If you get up before sunrise, before dawn, you will see Scorpius standing on its tail straight in the south, and Jupiter is in Scorpius this year. It'll be there all year. It'll move around a little bit, but it will be in the constellation Scorpius all year long. If you go back to the west from Scorpius, well, you'll see Libra, then you'll see Virgo, and then you'll see Leo getting over pretty far in the western sky. And hey, those are the stars of spring. And by the time you're getting to Scorpius and Sagittarius in the south, Jupiter's in Scorpius. Saturn is up there between Jupiter and Venus, and then Venus is the brilliant one that you cannot miss. Those are over more towards Sagittarius. And then at the same time, if you start looking up above the eastern horizon, well, you'll see the summer triangle. You'll see Altair and Aquila, you'll see the star Vega and Lyra, and you'll see the star Deneb and Cygnus. And those are the stars of summer. Okay, so summer's on its way, and it gives you something to look forward to. Right now, the moon is very old, but there's a very old crescent over to the east of Venus, low in the southeast before sunrise. And that's pretty much the sky, what's happening right now.
Wow.
I can talk
That's
about
amazing.
spring if you want, but
I
go
like
out and
hearing
look in
about
the
spring.
evening. Uh-huh.
I like hearing about spring. That's
Oh,
great
yeah.
that we get to
Wow.
see all that, and it means it's getting warmer and nicer. And
Yeah, well, it's the cycle of the seasons, and it's what our ancestors, they watched the sky every night, the medicine men or the scholars or,
Yeah.
The Greeks or whoever, the Akkadians. They watched this. They were not dummies. They, within the constraints of how they constructed their universe, so to speak, well, they knew quite well what was going on up in the sky.
That's true. And even the Babylonians were, they were saying that the earth is not the center of all things. They actually knew the earth was round. And in later centuries, that's when the strict interpretation was taken that the earth was not circling the sun, but it was actually the center of the solar system, and everything else was circling the earth. So that was actually the weirdest. I think that was the weirdest deviation of scientific accuracy, I think, in the history of humankind. That's my.
I've heard it. Somebody blamed the Greeks for that. Was it Ptolemy or I forget who it was?
Yeah, the Ptolemaic system was one where it did not include the Earth as the orbiting the sun. They thought that there were the epicycles. Remember, the cycles. These planets were in these cycles. That's how he explained how Venus and Mercury did their thing. However, if anyone noticed Venus and Mercury or had a telescope at the time, they would have seen that Venus has phases just like the moon, just smaller,
Yes.
and so does Mercury. So that would have told them that they are not the center of all things and that they are circling something much larger. Sun. Yeah. So
I'm sorry. Go ahead.
no, that's okay. I was just going to say that I'm enjoying the conversation here. And that's why I like to have you on, Daryl, because you like to, share with people things that I don't necessarily talk about because I'm a different astronomer. I'm a different kind of astronomer. I mean, there's many different kinds of astronomers, and they're all needed. If you have just me, well, that's a problem. If you have someone who does what I do only, well, then that's a problem. If I have someone like you who's a visual astronomer who can go outside and be totally at home by looking up and saying, hey, look at this, that's this, that's this. I mean, many of us can do that, but it takes a dedicated visual astronomer who's willing to go outside, say in the middle of winter, and hunt for a comet. And you've done that. And so my hat's off to you. You've probably, hopefully you still have all your toes and all your fingers and no frostbite is set in over time. But I mean, I think today you told me it was like 62 yesterday.
No, several days ago it was 62 Fahrenheit, and I was wearing shirt sleeves. I went out to run some errands and didn't bother taking a coat with me. Today it was 4 o'clock. It was 4 degrees above zero Fahrenheit. That's about 15 centigrade, minus 15 centigrade, Amanda.
thank you.
It was 4 degrees above zero and had maybe 6 inches of snow on the ground. It never got out of single digits all day today.
Wow.
It's going to go for another day or two, and then the sun's going to come back and melt all this snow. Thank God.
Yeah, see, we're in the middle of a blizzard right now. We're going to have anywhere from 8 to 12 inches by morning.
Wow.
Yeah. I had to go out and make sure that my tractor starts up. I use it's a bucket and a backhoe, and make sure I can clear the driveway with it if I need to. So it works fine, but let me tell you, I don't want to have to use it for that. I don't like winter, which is why we're moving everything to Arizona. You know, the SkyTour live stream observatory is moving to Arizona, and I'm still on that. I'm working on that actually, as not as we speak, but earlier this week I've been working on plans to get everything out of here, because you can't imagine what it's like. And we're looking at in a sky. When we look at the deep sky objects, we're seeing things that are kind of light polluted. It's really not the best. However, out there's certain areas out there where you don't have lights for like 100 miles. And I absolutely was flabbergasted with the fact that I could see my shadow from the light of the Milky Way. Okay, in some places.
When you wind up down there, I'll just say, make sure you're far enough south that you get a good view of Omega Centauri. If you've never seen it, that just blew my mind the one time I saw Omega Centauri. And you have to be pretty far south to see it. I was almost on the Mexico border.
Well, see, Omega Centauri, for those who don't know, is a globular cluster, a cluster of hundreds of thousands of stars. And it is the most stunning object in the sky next to the Orion Nebula, for those who see SkyTour live stream. The Orion Nebula, birthplace of stars, stellar nursery as we call it, right below the belt of Orion, that fuzzy little object you see just below the belt of Orion, that's actually a nebula 1,400 light years away, birthplace of other systems, other solar systems, star systems, I should say, and other stars. Amazing place. And we see things within the nebula called proplyds we've talked about, which actually are the beginnings of early star system formation with other potentially stars and planetary protoplanetary disks forming in there. That's incredible stuff. You know, we're in SkyTour livestream. We can actually see a little bit of a hint of some of these proplyds. And in time, I'm going to be able to allow us to see them a lot better. And I think that's going to be just tremendous. It's going to be a lot better for us. But
go look at today's APOD, Astrophoto of the Day at NASA. They have bullets, they call them, coming out of the Orion Nebula.
Yeah,
it is just a spectacular picture.
That's right. Those are wakes generated by the shockwave of stellar winds that are near these proplyds, and they cause these fans to be blown back from them. And speaking of fans, we want to keep our fans. So I think we're going to have to take a break here, and we'll come back in just a few minutes. I'm Mark D'Antonio with SkyTour Radio, here with Daryl Mason and Amanda Curran. We shall return after these messages. Hey folks, welcome back to SkyTour Radio. I'm Mark D'Antonio here with Daryl Mason and Amanda Curran. We are having fun tonight. We've talked about a whole bunch of things. We talked about the spring sky. We've talked about the stars that are upcoming and the stars that are out there now, the sky tonight, so to speak, with Daryl.
I gotta say, I absolutely love his analogies.
Isn't that great? I mean,
it is. It really breaks it down for, well, people like me anyway.
Well,
I love it. No, when you were saying about like Earth is in the fast lane or the left-hand lane, and Mars is trying to keep up behind him. Like, I mean, that people can relate to that, you know.
Well,
it's
what it's all about.
Exactly, and I appreciate that. I love having Daryl. Oh,
sure. Well, thank you, Amanda.
That's why Daryl is recognized as one of those people that's part of the SkyTour Radio family, right?
Yes.
Thank you.
He's one of us.
No. I need a hug.
Well, you know what? Amanda can give you one. I'll continue on with the show.
Carry on.
No worries. So, you know, I wanted to talk about a whole bunch of things tonight, but I want to talk about, there's an exoplanet roundup I'd like to go into. I was thinking of maybe putting it off for next week, but I'm actually going to do it now. because we're talking about the solar system and what's up in the sky and our planet. So I thought, why don't we talk about the most Earth-like planet found to date in the night sky, right? And that's known as Kepler 438b. Excuse me. And 438b is almost the size of the Earth. Now remember, the 438 is, Kepler 438 is the name of the star. And the 438b, little letter B as in beta, the little b indicates the planet. All right. So 438b is only literally 960 miles, which is 1,544 kilometers, larger than the Earth. Okay, so it's 1.12 times the Earth's radius. Now, it's 640 light years from the Earth, although that number, I've seen that number change. Light year distance is not exactly known. And 438b, that little planet, circles the star every 35 days. Yet, it's in the habitable zone for this star. How can that happen? It can happen if the star has a lot less output than our sun. And what stars have we talked about in the past that are much smaller, little percolators that sit out there in the universe and last maybe trillions of years? Well, those are the red dwarfs. Okay. And Amanda knows the spectral classes that we talk about. So Amanda, if you could be so kind as to tell people the spectral classes. I know you know them.
Okay. OBAFGKM. And that's hottest to coolest, blue to red, biggest to smallest.
Well, you look at that. I'm proud of you. If you think about this, she knew none of that before, folks. Now she does. She's been exposed to it. She understands. We go through it in SkyTour live stream when we show these different types of stars. Well, anyway, the way it works is this is a little tiny red dwarf around which 438b is orbiting. It's literally half the mass of the sun and half the radius of the sun. It's small. And the planet itself is small and rocky, likely. So we think it's terrestrial and not a gas planet. And I won't say gas giant because it's too small to be a gas giant of any kind. And we haven't seen any planets in our solar system anyway, or around other solar systems that we can tell, that would be gaseous that small. Okay, and so we think that maybe we're talking about a small, rocky, and maybe likely terrestrial planet. All right. And these gas giants tend to be larger. But for this particular planet, all right, when we're talking about 438b, it's orbiting literally 15 million miles from its star. That's 0.16 astronomical units, okay, or 25 million kilometers. Now, keep in mind that Mercury orbits at 36 million miles from our sun. So 15 million miles is less than half of the distance, and that's the habitable zone. If it was a star like our sun, well, that planet would be scorched and baked. There'd be no life there. But the question is, could we survive there in this planet that's now in the habitable zone around this star? Here, the prerequisite for life like us is liquid water is available on the surface. Okay, oxygen in the atmosphere in part makes for a habitable zone for us, a habitable place. And reasonable temperatures. Further, we need a stable environment. The planet has to be stable. But 438b, the planet is actually prone to these outbursts of this stellar radiation, probably in the ultraviolet, UV. And the UV radiation from this M star could possibly make life and evolution improbable there. But perhaps not. Now, I say that because think about the Earth. We've had a number of global extinction level events. No, our sun hasn't thrown off ultraviolet radiation that wiped out lots of life. But we've had asteroids strike the planet. In the Permian period, 252 million years ago, mammals, precursors to mammals, precursors to us, were the dominant species. But at the impact that killed a lot of the species, 96% of them, mammals were forced to retreat into the shadows, and reptiles came to the forefront because they were the least affected by that particular quote unquote great dying that occurred. And then 65 million years ago, the age of the reptiles came to an end when the asteroid struck off the Yucatan Peninsula and wiped out the dinosaurs. And when that happened, mammals now saw all these empty niches and they could fill them again because they were not as affected as the reptiles were. So you see, because of those extinction events, we are as we are today. Without them, who knows what we would have been, if at all. So a planet like this that we're talking about, 438b, that has these UV radiation flares that come from the star, well, maybe those cause the extinction level events on that planet over time. And maybe that is something that life there, if any, has adapted to and continued through as we have after our extinction event. It's just a really interesting philosophical pondering that one does to try and figure this stuff out. It's just amazing, you know. But look,
may I ask?
Yeah.
If the planet is only 15 million miles away from its sun, I would have to think there's a good chance that planet is tidally locked.
That's right.
Which would certainly affect, the biosphere of the planet, I guess you would say. It's interesting to think about.
Yeah. And that and Daryl did not burst the bubble here because that was the next point I was heading to because I was talking.
I'm sorry.
No, you didn't. That's why I made it very clear. That's exactly.
I do that all the time. Don't worry.
No, neither of you did. Stop. Here's what the thing is that this. You know what it shows? It shows that you guys are thinking. You know, you're synthesizing answers. That's not a bad thing. I'll never.
Or it shows that I'm impatient because I ask a question. You're like, I was just getting there, and I'm like,
Okay.
If I had just waited, I would have had my answer. But
Amanda, accept the compliment. Accept the compliment. Move on.
Nah.
That's okay. No, but yes, if the planet is that close to the sun, to its star, as Daryl suspects, it's probably tidally locked, which means the same face is always facing that star. Now that means that there's probably a wonderful possibility of communities along the terminator, the part where it goes from light to dark. All right.
Exactly.
Yeah. And that could mean travel agencies can have a boon. They could have a night side star tour package. They could have a perpetual sunset photography package and a beach package, you know, courtesy, well, as long as the ultraviolet flares are not, there. But maybe they'll just use the higher level of sunscreen. Honestly, I think that's pretty cool. I would actually like to visit a planet that's tidally locked, because then we can actually see how that works. There's a lot of papers actually out there that talk about, could a ecosystem, could a system of life live on the terminator, that is the light and dark separation zone on a planet, where the radiation will be minimal or minimized anyway, but still have enough light and still have enough dark to actually forge and eke out some type of existence. I don't think that precludes life from forming. It could just be a different form of life. There might be sunside life forms and there might be nightside life forms. Maybe they would develop different ways of navigating. Maybe the nightside life forms will develop sonar type navigation like bats. And the daytime might develop certain eyes with shields to prevent the UV radiation from hurting them. And maybe the ones on the light side can't go to the dark side and vice versa. So I think there's an awful lot of very interesting possibilities and very interesting science fiction that we can come up with all of this. I think it's so cool. Now, I've said it before, when we look at our own planet, which is the womb of humanity in the cosmos, our planet may not be the most friendly planet to our species, okay, such as it is, weak as we are. So it's possible that other Earth-like planets out there are better suited to the continuance of life. 438b might not be that planet, but it certainly might offer advantages if it doesn't have the same type of weather, if it doesn't have the same type of crustal plates. So, for instance, here people are being killed by hurricanes and tornadoes, earthquakes and tsunamis. And those latter disasters there, the earthquakes and tsunamis, are brought about by our dynamic crustal plates moving around, grinding inexorably against each other, okay, causing these earthquakes, causing tsunamis when it causes earthquakes, when these faults slip, okay? And that's something that is really, really, difficult to fathom. How a planet like this one around 438b might actually be one that we might be able to move to at some point. I don't know. I think that there's a strong possibility that there might be life there that's persistent. I don't think UV totally negates the possibilities, but that's just me. Now, in that regard, we talk about the search for life in the solar system in the same way. We're searching on Mars, okay? Now, the search for extraterrestrial life in our own solar system is a complex, fascinating journey, and understanding how life develops can dictate the methods that we use to hunt for life beyond the solar system. And okay, so our methods spring from this understanding. So let's talk about a little bit of that, right? And this is sort of our feature, the search for extraterrestrial life in the solar system and beyond. So, if we talk about the exoplanet 438b, we understand some of the problems with 438b. The tidal locking could be a problem. The UV, the ultraviolet radiation, could be a problem. However, it could also be that a life form has managed to adapt. The key word, adapt. Life adapts. And that's something we see on Earth with the millions and billions, actually, of species that have come and gone and that are still here. Life adapted. And so that adaptation taught us that it's not necessarily false that there's life elsewhere, even in our solar system. So with that in mind, every single mission to the outer planets has had the search for life in some fashion at the forefront of its main tasks. And it goes all the way back to many early Martian missions, but most assuredly Viking 1 and 2. They had ovens on board Viking 1 and 2. A little more than the easy bake oven, okay? But they had these ovens to actually bake samples that were captured with a robotic arm. And these landers, Viking 1 and Viking 2, wherever they landed, that's where they stayed. In the early days, wow, we were just like, look at this panorama of Mars. Wow, that's so cool. We thought that was the best thing. Now we think it's boring because we want to rove around. All right. So the ovens on Viking project, the ovens actually would cook these samples, and the outgas, that is the results of that cooking, they could detect what it was. And based on any materials that were in there that may have fostered life, then the cooked components might give that away. And that's what Viking 1 and 2 did. Okay, they cooked in their ovens. Now there's some controversy about whether they actually found anything, and it's not a conspiracy. It's just controversy because they may have missed the indications because the nature of the way that science experiments were actually designed at the time. Okay, after Viking 1 and 2, and these aren't necessarily in like they're in linear year order, but not, they're not separated by a certain number of years. Okay, they're just the next one that mattered was the Pathfinder mission. And Pathfinder was interesting because it used this technology. It was actually a demonstrator project. It delivered the rover to Mars using the airbag system. You remember that? This airbag would bounce on Mars, boom, and then bounce way up high in the sky, and then boom. And it would bounce for a half hour, 45 minutes before it slowed down in the lower gravity of Mars. And these airbags were just constantly soaking up the impact with every bounce. And then it came the rest. The airbags deflated, and this tetrahedral system opened up. And no matter which way it landed, it could open up so that the rover could drive off. And that's what it did. and Mars Pathfinder did that. But Pathfinder also told us something very important about Mars. Mars' surface is bathed in ultraviolet radiation, just like 438b's surface could be at times. However, Pathfinder showed us that Mars' surface was wet in the past, very wet. All right, the clues were there. All right, so even back in Pathfinder, Viking 1 and 2 may have been, didn't show us exactly what we wanted to see, but Pathfinder did. Okay, after Pathfinder, there was Mars Odyssey. That was an orbiter, and orbiting Mars looking for evidence of water and ice is what it did, which is a prerequisite for life as we know it, of course. And it found it. It found water and lots of ice. Okay, but it also did something else. It created a risk assessment for astronauts by studying the radiation environment of Mars. And that radiation environment of Mars was critical to understand because we are going to go there someday. We are. We can't stay away. It's red. We like red things. So, and after, that was a joke. After Mars Odyssey, there's Mars Express. Now, that was the European Space Agency's first planetary mission. And on board the Mars Express, they actually had the Beagle 2 lander, which was to study the chemistry of Mars, offering clues of past life presence. Unfortunately, Beagle 2 failed to fully deploy upon landing, and it didn't get the chance to perform its mission. Now, since then, other Mars orbiters have since photographed Beagle 2 sitting on the plane, remain covered in ice and frozen for all eternity. Sad to say, it's like a car in the front lawn. It's not going anywhere forever. So Mars Express, though, did give us clues about Mars regardless. After Mars Express, there was Spirit and Opportunity. Spirit operated from 2004 to 2010. Not a bad run for a probe or for a lander that was only supposed to live for 90 days. They thought it was going to live for 90 days. 2004 to 2010, yeah, they got more than their money's worth for sure. That thing owed them nothing when it died. Well, it didn't even die. The wheel got stuck, and then over time. But, Spirit examined the precipitation amounts from past events. It looked for clues that there might be a water cycle that existed at some point. What's the water cycle? Well, lakes evaporate water. Water goes up into clouds. Clouds rain down into the soils. The soils runs off to the lakes, and the cycle continues again. That's the water cycle. And it found clues that there might have been a water cycle on Mars as well. It also looked for certain minerals that could only form in the presence of water. And it was brilliantly successful in identifying as such. And these little blueberries that were found there were obvious from almost day one, which I thought was pretty cool. Now, Opportunity landed on the other side of the planet, and that operated from 2004 until just a few months ago in 2018. It actually exceeded Spirit by years. Another amazing success story. And I gotta say, look, I have to give kudos to the teams that developed these rovers. They thought of almost everything. And in the future, there's actually a mission on the docket for sending a drone to Mars in the form of a helicopter. And I watched testing of the helicopter, and the helicopter in a reduced environment where they actually took out most of the air to simulate Martian atmosphere. This helicopter flew just beautifully. It was stunning, and it wasn't small. I mean, it was a drone, bigger than the drones you buy in the store, of course, but it was meant to give an aerial view of the landing area and look at what's around to see if a rover can go visiting that different area. Just incredible. So, I mean, the results from Opportunity were astonishing, and at the same time, there were orbiters circling Mars that were actually mapping using ground penetrating radar. Were mapping the poles and discovered a lake, an actual lake, a mile below the surface and many miles long. Now, what does that tell you? That tells you that the pressure and temperature down there might have been such that liquid water could exist. And if liquid water could exist, well, you know what that means? It means that now that's one of the prerequisites for life as we know it, right? The temperature was reasonable and it had water. And the water wasn't or isn't acidic as far as we can tell. So maybe we're looking at salty water. So a small undersurface, subsurface ocean of sort of lake, more likely. So I think that's pretty cool. Now it's really, the Mars Insight mission. Okay, actually I got to go back a little bit. We talked about Opportunity. After Opportunity was the Phoenix lander. And speaking of water, and the Phoenix lander assessed the water content on Mars, but it also looked at local habitability, meaning if we were to land here, could we survive here based on the local resources and materials? All right. And the answer is, well, maybe we can, because there's other processes that show we can get oxygen out of the carbon dioxide. And that's a test they're going to put up with the Mars 2020 mission when that goes up. And so, the habitability question comes from being able to synthesize what humans need to survive on Mars, wherever we land on Mars. And that question is actually going to be answered fairly quickly, I think, as we move forward. The next lander was Curiosity, and that was the most complete laboratory ever sent to Mars. And it's still in operation, and it has been since 2012. Another mission that was meant to only last 90 days. 2012. Yeah, we got our money's worth. And I think that this is most important to understand. It searched where it landed. It's called Gale Crater, Gale, Gale Crater, which was the former site of a potential lake for evidence of life, either now or in the past. Keep in mind that at the surface, the UV radiation from the sun has pretty much sterilized the near surface. Okay, we have to penetrate down into Mars to see what's going on, to get a better idea. But let's skip ahead a few missions to Mars Insight. Mars Insight just landed a few months ago. It's going to study the Martian deep interior to assess if Mars has an active core or not. Now, it doesn't have a magnetic field, so the core may not be active, but we need to know if it can support habitation in the long term. And, Mars isn't the only place we want to go to actually look for this, okay? But InSight is going to study a number of factors, like how much heat is escaping from Mars. That tells us a great deal about the core. And that's something that we're gonna learn from, all right? And as Amanda loves to talk about, there's one mission planned for Mars that might actually be able to put a fake magnetic field at Mars, so that Mars could terraform itself, and the results would be almost fairly immediate, because carbon dioxide won't be broken apart. Oxygen molecules that are generated here and there won't be broken apart. They will actually be in good shape. So if we can figure that out, then Mars could actually be a terraformable location, and the terraforming doesn't have to be done by anybody or anything, except Mars will do it itself. It'll take time, but Mars could do it itself, as long as the ultraviolet radiation and the very, very powerful solar wind doesn't have a chance to destroy anything. So other missions are flybys of Europa at Jupiter. I mean, Europa has all these geysers that are spewing. The Hubble Space Telescope saw these geysers spewing this material, water, ice at the very least. So they're called cryovolcanoes because it's icy water. And so there's a mission plan to Europa. It's called the Europa Clipper. It's going to be an observational one. It's going to look for a landing site, followed by the Europa Lander, which is going to, in a later mission, land there. So you see, we are looking for this tenacious thing called life. We think that life can exist on many different places. Enceladus at Saturn. It's a tiny little 300-mile diameter moon. But we think maybe under the icy mantle, like at Europa, there might be potential for life, because we see hydrothermal vent activity going on at the South Pole. That is something. Stephen Hawking said, We are human, and we want to know. That is very, very true. So we move outward and look at our solar system with an eye on the universe. And we'll talk more about that when we come back after these words. I'm Mark Antonio. This is Sky Tour Radio. Hey folks, welcome back to Sky Tour Radio. I'm Mark Antonio here with Daryl Mason and Amanda Curran. I mean, I kind of dominated the last segment because we were talking about the interesting Martian missions. And Daryl said something really interesting in the break. He said, wouldn't it be interesting if that helicopter that they're going to send to Mars, could just fly over Opportunity and dust off the panels? Sure, that's a great idea. Because if you think about it, that multi-million, hundreds of millions of dollar mission has been thwarted by the fact that Opportunity's batteries can't be charged efficiently at the moment. Now, once the cold gets to them, then they're going to be dead and nothing can restart them. But think about that. That would be a really cool possibility, So we're talking about the tenacity of life and getting out to the outer solar system, the inner solar system, and looking for possibilities of life. Now, we want to take it to the next level here and say, well, one thing that we've learned from studying our own world is that the tenacity of life here on Earth is absolutely mind-boggling and breathtaking. We find life in hot springs. We find life right near active volcanic vents. We find life deep in the ocean under pressures that are thousands of pounds per square inch. Pressures that would kill you in an instant are absolute thriving conditions for some of these creatures. Recall, I don't know if many of you may not remember this, but maybe you will. Recall there was a what's called a colony creature. I'll explain that. That was brought up from the depths, and this creature was brought up from thousands of feet down, and it was a creature called a siphonophore. What the heck is that? Well, Siphon 04. Okay. A siphonophore is related to jellyfish, and it was brought up under high pressure in its living conditions. And by the time it got to the surface that we live in for easily, that pressure up here was too low for it to survive. It burst and broke into many tiny little creatures before dying. And I say tiny little creatures. What's that mean? Well, it was a colony creature. All right, and siphonophores are colony type creatures. So it's possible that these, and we know it's true, its native environment was inhospitable to us, but it was very hospitable to that particular creature. And such is the way of evolution of animals here on the Earth. We see this across the animal kingdom. Each niche has specializations, whether it's through, at certain depths, certain altitudes even, certain temperatures, cold or extreme heat, or where it's oxygenated or no oxygen exists at all, where there's light or where there's no light. Every one of these niches are filled with life, every single one of them. And none of them precludes life from forming, except in the heart of lava in a volcano. That's the only place that we have yet, I should say, to find any life forms that exist. All right? They exist almost everywhere else. And these niches have evolved their own species that thrive under those conditions. But there are caveats. A deep sea specialization precludes any creature from those depths ever seeing the light of day, as we just illustrated with this one siphonophore that was brought up from the deep ocean. Okay, so the deep sea creatures coming to the surface is like us heading to the edge of space without a spacesuit. We can't survive there without special, accoutrements and gear. It's an interesting to talk about these siphonophores a little bit as it relates to ET life. Siphonophores are colony creatures. They're made up of many identical and independent bodies that together form one cohesive self-directed animal, whatever self-directed means in this case. Their existence is an odd one, I got to say. And the odd thing about this is, it points to colony creatures on our planet at various levels. Okay, there are many different types of colony creatures, and we know them. Ants, bees, they're colony creatures. They have highly specialized social structures that work toward one goal. All right. Every single individual has one goal, knows its job from the moment of birth, and does only that job until it dies. There's no rogues. There's no deviants. They're all on the same page always. I mean, that's pretty amazing. That's nature programming nature. It's crazy. Now, there's other colony creatures on Earth, such as the siphonophores, and dozens of other species. Now, there's various types of colony, definitions of colony. Okay, you have a social colony. Okay, those are things like slime molds. I've never seen a slime mold myself. I don't know if I want to. It sounds like something that's gross, but I'm sure it's not. I mean, but it's a colony creature. Okay, social colony creature. Then you have these things. Another type of social colony is a eusocial, 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 and that includes bees, ants, and termites. And they have brood care. They take care of the young. They have reproduction versus non-reproductive tasks, and in many cases, a caste-based system. Caste, CASTE, a caste-based social structure, and you can't do anything outside that caste, or you won't survive. That's really interesting to me. And then we have the most interesting one, which I think these are actually called modular organisms, like things like a clonal colony. What's that? Clones, a series of identical clones, all right? And they could be all physically connected into a single animal, all right, that work together yet are independent. That is pretty interesting because that brings me down a whole nother path, which I'll get to shortly. But think about this. Single and multicellular creatures can exist this way. There's one called the Volvox, VOLVOX. All right, it's a single-celled clonal animal, okay, made up of single cells, but very many of them. And then there's bryozoans, which are filter-feeding multicellular moss-based animals. Moss animals are very, very small animals. So what does this have to do with ET life in the universe? Okay, well, I think what's interesting is if there's this type of life out there in our world, then we have to be aware that maybe this exists in the universe. If UFO reports are of any value, for instance, then we can't ignore the possibility that there might be colony-based or hive-based creatures that came into existence on other worlds and then reached some level of collective intelligence. Now, it's often been reported by people who experience these odd events and what we call abductions in the UFO world, that maybe these potential visitors are actually clones or actually hive minds, where they kind of know what's going on and don't really seem to necessarily talk to each other, but communicate through different means. That's exactly how hives here work with our creatures here. So maybe we're seeing an offshoot, a different type of hive mind technology that's out there. Maybe that's what we see in a creature that actually evolved a different way on a different planet, but was a clonal colony or a colony creature of some type, or a hive. You can be pretty much the same. A caste-based social structure, possibly, like we see here. Again, drawing hints from the Earth itself and from life here. Maybe those are analogs to life elsewhere. But if you accelerate and put them at different levels, I mean, just imagine intelligent ants, for instance. Intelligent ants would possibly act the way that the quote-unquote grays do when they quote-unquote abduct people. I say quote-unquote because, whereas the possibility that the abductions really are taking place are out there, erring on the side of the science, I mean, I don't necessarily believe that they're not here at all. I think that they very likely could be, based on everything I know, and what I feel about the science and what it tells me personally. But it may not be the case that that they're here all the time. Maybe they come. Maybe they're here. for the last 300 years, and maybe before that they weren't here for 4,000 years, or they were, or they weren't. I mean, we don't know their scale. Just because we're alive now doesn't mean they're here now. I do this toilet paper history of the Earth, right? Have the entire history of the Earth on a 117-foot roll of toilet paper. And when you see all the developments of life and where it comes across this toilet paper, you get all the way to the end, which is us in the room today. You see dinosaurs are 18 inches away. That's where dinosaurs died on that 117-foot scale. And you say, wow, well, dinosaurs are recent history, not ancient history. But if there was going to be a visitation to our planet, it could have occurred anywhere along that 117 feet. See? And not necessarily, it may not be necessarily that they were here during the dinosaurs. Maybe they're here now, but they weren't before. We don't know. That's all the stuff that we talk about. So that's kind of an interesting thing. And I just want to, take that to another place too. And that is when we talk about, life on Earth and how life developed, we know that there's a really extensive history here on this planet. We also know that in our own solar system, there are places that have been called a snapshot of an early Earth. Okay, for instance, Titan, Saturn's moon Titan, which I haven't mentioned till now. Okay, the Cassini-Huygens probe landed on Titan, lived a short time because it's so cold. Water's as hard as granite down there, but there were lakes of hydrocarbons that were there because the temperature was low enough, pressure high enough, okay, and ethane, right? And it was basically, it's a moon of Saturn that actually has the same primordial materials that the Earth might have had. Now, I think that's pretty interesting. And right here on the Earth, are you aware that we have a similar location on our own planet that isn't really the same as Titan? It's not nearly as cold, but it's as isolated as ever. And it's the nearest analog to potentially to what's going on in Titan. And that location is in Antarctica, but it's 2.5 miles under the Antarctic ice. And it's called Lake Vostok. It's a deep lake, all right? And this lake, like I said, is 2.5 miles under. It's 4 kilometers. And it's been under these miles of frozen ice in Antarctica for millions of years. Yet, they said, okay, we think there's a lake down there. Let's drill. And they drilled down, and it was called Vostok Station. And they reached the lake. And the announcement that they found life in this lake led to criticisms. Oh, well, it was just contaminants from the surface, and the long drilling process led to, accidental momentary seeding of life there. It was all an accident. But then with the latest announcement, that was dispelled utterly and ultimately because Lake Vostok has over 3,500 independent species that have been thriving, not just in the dark, airless world, but in the world without photosynthesis, where you can't see the light. In this without the sun, they're thriving. 3,500 independent species down there. So it shouldn't have been surprising considering life has been found in the volcanoes, as I said, the hot springs, places that are deadly to humans. And even floating free in our upper atmosphere. How about that? As well as on the outside of the ISS. So I've said it many times before. I even said it once tonight. Life will find a way. My favorite quote by Jeff Goldblum, who played Ian Malcolm in Jurassic Park. Okay, and it's not just a movie script, but it's reality. Okay, some life forms indeed are just bacteria. All right, but they found hundreds of species of what's called eukaryotic life. Now, eukaryotic means single-celled life, at the very least, with a cell membrane and a nucleus. And additionally, they found over 100 multicellular species, including species associated with fish and mollusks. Now, it doesn't mean there were fish and mollusks. There weren't. But there were species that were precursor species to these. The same kind of things that are found in fish and mollusks were there. Mollusks, remember, are 50,000 species strong on the earth and include the octopus, squid, clams, scallops, oysters, etc. Okay. Now, the lake is actually more inhospitable than the surface. Okay, for sure. And under that much ice pressure, it is enormous. The surface of the lake gets higher. The pressure gets higher with depth under the lake. And the air temperatures, while they drilled at Vostok Station, were the coldest ever found on the planet. Minus 89 Celsius or minus 128 degrees Fahrenheit. Those are the temperatures on the drill head. Okay, not down on the lake, but at the drill head on the surface. Now keep in mind, carbon dioxide, what you breathe out, freezes out of the air and will fall at like snow at minus 78 Celsius, which is only 109 below zero Fahrenheit. And the temperature at the surface was minus 128. So you can see that location, coldest on planet Earth, and Lake Vostok is slowly giving up its secrets. And this is paramount, of paramount importance to us, because beyond the thing that happened throughout the lake is they found species that are operating at every stage of what's called the nitrogen and carbon cycles. Now, why is that important? It just sounds like two elements. Yeah, it is. But nitrogen and carbon cycles drive life cycles on the surface all over the place on this planet. And to find them fully in play 2.5 miles down in Lake Vostok is incredible, where there's no light, no photosynthesis, no sunlight, nothing. No access to the atmosphere either, by the way. The lake is isolated from the surface and has been for over 1 million years, as I said. So how does this work? I'm not going to go into all the details and all that, because that's just crazy, depth we don't need to go into. Haha, no pun intended. But 78% of our atmosphere is nitrogen, and it's actually N2, diatomic nitrogen molecules. And the nitrogen cycle occurs in life forms, okay? The atmospheric nitrogen is basically converted into a form that's useful to biological processes. Well, this is happening in the lake. And also happening on the Earth up above is something called the carbon cycle. It's a continuous cycle where different processes exchange carbon between the air, the water, and the land. Now, a little bit of detail about that is, in the atmosphere, we have carbon dioxide, we have methane, greenhouse gases. And without which the Earth would actually be pretty frigid. So CO2 is out there in the atmosphere. It's removed from the atmosphere via photosynthesis. Yay, plants. Now, not just plants like we have on land, but also plankton in the ocean. Plankton and plants are equal partners in the generation of this carbon dioxide reduction and oxygen production. All right. They're equal partners. They do the same amount. So carbon dioxide is also removed by water itself through direct absorption by these bodies of water. So water absorbs carbon dioxide and produces this weak acid called carbonic acid. You've done the experiment where you blow through a straw through a certain liquid, the water becomes cloudy. Okay, that's carbonic acid caused by your CO2. And the oceans are what are known as carbon sinks. They accept carbon dioxide. They can suck it out of the atmosphere. Okay. Now, on the land, what you call the geosphere, there's other ways that carbon dioxide is actually transported around. Okay. Another part of the carbon cycle. The geologic processes, though, move slower than air and water, carbon transport. And they involve the crustal plates moving around, diving under each other at the boundaries, causing these metamorphosis of rocks that used to be sedimentary. And these sedimentary rocks then would become, metamorphosed. That is, they're high temperature and pressure. They change into a different type of rock. So, for instance, limestone, under great heat and pressure becomes marble. All right. But during that process, carbon dioxide is released. And the carbon dioxide that gets released is released into the atmosphere. All right. And we see it coming out with volcanic eruptions. Now, let's go back to Lake Vostok now. Now, hearing that's all the up above. Both of these cycles, the nitrogen and the carbon cycle, are in full swing in Lake Vostok. And because the carbon doesn't come from the CO2 in the air, there isn't any atmospheric, CO2 down there. And there isn't nitrogen from the atmosphere either. So what it means is that Lake Vostok is the ultimate green ecosystem. It's managed to create these cycles very efficiently just from its own available carbon and nitrogen in its local environment. That's a very important finding. It means that Lake Vostok wastes nothing and produces what it needs for 3,500 plus species to thrive. And it's a closed system, and a rather small one at that, typically. So why is this important? Let's go out to Europa. It's 1,945 miles in diameter. That's 3,130 kilometers across. And it's spewing these icy geysers. These were first experienced by the Galileo spacecraft in the late 90s and then seen by the Hubble spacecraft in photos taken of the moon from here. And it identified water spewing from within the moon. Now, NASA is going to get 2 missions out to Europa because just like Lake Vostok, it's possible that Europa has the same closed system that it generated. Can you imagine that? That should be the coolest thing on since sliced bread, if you think sliced bread is cool. I tend to prefer to cut it, like rye or loaves. Just cut them really thick, that's me. Anyway, in 2023, the Europa Clipper will go. I talked about that earlier. And that's going to orbit Europa and find a likely landing spot. But then in 2025, just 2 years later, is the Europa Lander. That's going to land in a selected site that the Clipper found, drill into the surface to see if organic or carbon-based molecules exist there. Now, if you're worried about contaminating the ocean underneath, the reason that we're not worried about it too much is because the surface of Europa is going to be pretty dynamic, but it's also going to have the lander drilling in a short distance, and over time, any organic molecules that came out and mixed in with the ices that are in that crust up above will be seen, and we'll be able to see exactly what's going on underneath. So, so that's Europa. Now, Europa may have that, like I've said before, 90-mile deep ocean. I've heard 60 miles deep, but you know what? 90 miles is possible as well. I just think that's amazing. So now, if we could get to Saturn's a lot farther, and it's a huge undertaking. But we could get to Enceladus. Now, Enceladus is one of Saturn's moons. Obviously, it's only 310 miles across. It's tiny. But it has geysers at the South Pole. And they're spewing diatomic hydrogen. What's that? H2. Well, why is that important? Well, it's very important because it's also spewing carbon, which if you have hydrogen and carbon molecules, they tend to form methane. And methane is found spewing from the deep ocean vents here on the Earth. And the parallels are hard to ignore, all right? They're really hard to ignore. It's important to understand that. So Europa is attractive for a similar reason, okay? And further missions will show if our suspicion that life will find a way are correct. But until we find life in the deep ocean, until we found life, actually, at these hydrothermal vents, we would never have expected to find or hoped to find life at Europa, okay, or Enceladus. And, of course, the jury is still out on that. We don't know if it's there. But we never expected to see the abundance of life that we have seen. We didn't expect to find 3,500 plus species in Lake Vostok. Incredible. Humans, we're dependent on photosynthesis, although we get, vitamin production stimulated by the sunlight. We could live without it if we had to and get it artificially, but we're the surface dwellers, but all the foods we eat are part of the vast chain that begins with photosynthetic life forms. Without photosynthesis, humans don't exist. All right. So chemosynthesis maybe can offer life forms up to a certain level, but not sure that can happen. So, here, the deep ocean is very different. Okay. We depend on photosynthesis. However, in the deep ocean, it's chemical synthesis, right? The water's laden with methane, which is a carbon atom and 4 hydrogens. And so CH4. And methane-eating bacteria spawn here in droves, and they eat this methane. They love it. And then animals that eat the bacteria thrive, and the chain goes on and on. More advanced life forms feeding on lesser life forms, etc. So like Lake Vostok, sulfide chimneys like Lake Vostok. It's like a tongue twister. Like Lake Vostok, sulfide chimneys, these black smokers as they're called, are somewhat of an encapsulated world. They have debris from the lit world above filtered down on them, but they're not dependent on it. And that phenomenon is known as sea snow, when the stuff up above filters down. That's all dead stuff that's falling on your head if you're in a deep ocean. Kind of gross. But the chimney populations of life are all dependent on the chemosynthetic source. Really cool. So it's really interesting to talk about. The world uses this. This world uses chemical energy in the dark abyss to make energy. In the dark there, that's the chemosynthetic life. On the surface, it's photosynthetic life, needing the sun. But I'll tell you, there's a lot of processes that have occurred on our planet that are just amazing. And sooner or later, we're going to crack this code. We're going to figure out where these life forms are out in our own solar system. And we might find it's very common that there might be, it's commonly understood that there's life forms underneath the Europa ice mantle. It's possible. We don't know. Now here on this planet, all life forms have DNA in common, deoxyribonucleic acid. And they also have RNA, which is a messenger, basically, that carries instructions that allow proteins to be made, which is interesting, okay? And is that common in the universe? Maybe it is. Maybe it is. But carbon is essential to all life on Earth. And so as people that, are built on carbon atoms, we have a right to search for other carbon-based life. We're not carbon bigots. We're not carbon chauvinists, but we are searching for life like us because we know what to look for. We know what to look for. So, I hope that you enjoyed this, because this was sort of a foray into the search for extraterrestrial life by looking at our planet and looking at the moons in the solar system. And next week we'll talk a little bit more about that. There's some more to do there, but I think we did I think we covered it pretty well tonight. In any case, on behalf of Amanda, myself, and of course Daryl, I want to wish you all a good evening, and don't forget, keep looking up. This is Mark. Yeah, that's right. This is Mark at Sky Tour Radio with Amanda and Daryl, and we'll see you next week.